Hey guys, welcome back. Today we're going to go through LeetCode problem 1561, maximum number of coins you can get. Let's take a look at the problem first. There are 3 n piles of coins of varying size. You and your friends will take piles of coins as follows. So in each step, you will first choose any 3 piles of coins, not necessarily consecutive. So it might get a bit confusing and tricky here. So the first step is that you, as a participant, to take 3 coins out of this given coin piles. And then of your choice, Alice will take first. So Alice will pick the pile with the maximum number of coins. And then the second person is your turn. So you pick the next pile with the maximum number of coins. And Bob will be the third person. Your friend Bob will pick the last pile. So each time you pick 3 piles or 3 coins, Alice takes first one, you take the next one, and Bob take the last one. So this is the rule to play this game. Repeat until there are no more piles of coins. So the number of coins is 3n, so it's divisible by 3, so it makes sure that everybody gets equal number of coins in the end, that is n. Given an array of integers piles, where piles I is the number of coins in the ith pile. What it means is the value of the ith pile. That's what it means. Return the maximum number of coins which you can have. So for example, given this pile, a total of 6 coins, 2, 4, 1, 2, 7, 8. The output is 9. So let's take a look at the explanation of how it works. First, you pick this triplet, 2, 7, 8. The maximum one is 8, so Alex picks this one, and then you pick 7. The last one, 2, is given to Bob. Then the remaining one is 1, 2, 4. And also in this example, I don't know if they intentionally misordered this triplet, because 2, 7, 8 is here, and then the next one should be 2, 4, 1, but instead they put 1, 2, 4. This might create another layer of confusion, but it doesn't really matter because all of the 3 people, they are picking by the maximum value. So the 4 is the maximum in this triplet, so Alice will pick 4, and then you pick 2, Bob will pick 1. So in the end, you get 7 plus 2, that is 9. That is the maximum that you can get. Take a look at the second example, 2, 4, 5. So there's only 3 coins. So Alice will pick the first one, which has the maximum value, which is 5. Then you pick the next one, which has the maximum value, which is 4. So output is 4. Okay, now let's take a look at example 3. For this example, what we can do is that if we don't do any pre-processing, we can just take a look at this one. What it does is 9, 8, 7. So 9 gives to Alice, we take 8. So that is 8 plus. Now 6, 5, and 1. So 6, 5, and 1. So 6 is going to give to Alice, and then we pick 5. And next 2, 3, and 4. So we have to get 3. So in this case, we're going to get 16. Apparently, it's not super ideal. If we don't do any pre-processing, it's going to give us the number that we can get. I, as a participant of this game, is going to get the maximum value is 16 instead of the correct output, which is 18. So let's just quickly think about how we can approach this problem. Should we apply a sorting to the given input? What's going to benefit? What's going to bring us if we apply sorting to this given pile first before we do any processing? So that's if we sort this given pile, it's going to give us the minimum number is going to be coming first, and the maximum number is going to be put in the very last towards the end of this array. And what I, as a participant of this game, can take is always the middle one. Right? So the minimum one will be given to Bob, and the maximum one will be given to Alice. So whatever is left in the middle, I want to take the one as far right as possible, because far right, that means the bigger one, the coin with bigger value, right? That means the biggest one will always be reserved to Alice, but then I can take the second biggest one. The smallest one will always be given to Bob. If we can think of that, that will make things a lot easier. So we'll sort it first, and then we always pick the second last from the right end. And then we can add all of them up. That will give us the correct answer. I hope that makes sense. If that does, now let's put it into actual code. All right. First, let's sort this array. It's called piles. Now we'll have two variables. The one we'll just call it j, which is going to give us a count, say, because every person, there's a total of 3 n piles and 3 participants, 3 players are involved in this game. So whenever I picked n coins, so at that time, we'll just break out. So another one is, so I is going to start from the second last element, right? So that's going to be piles, let me call it len, piles length, and then -2. So the last element is going to be len -1, so the second last element is going to be len -2. And then I must be greater than 0 because we will be like right in the 1/3 point of this entire array, because for the very first 1/3 part is going to be reserved for Bob, right? So I greater than 0 is good enough. It's not precise, but it will be good. And then because we will have a break in the for loop, so this I greater than 0 doesn't really matter. We can actually remove that later on. And then here I is going to be decremented by 2 at one time. Why? Because the first one, the current biggest one, will always be reserved to Alice. All right, so that's why we start from the very right end. Okay, now I have another variable called coins. Start from 0. Now coins will just add up all of the values. And then next, what we want to do is that we want to make sure that j, we will increment j. That means I, as a participant of the game, have collected one more coin. So I'm going to increment j. If j equals to len divided by 3, that means, so the given piles of coin is 3n. So that means I got n coins already. At that point, we can just break out and return. Otherwise, we'll just also return as well. This is the entire algorithm. So now let's hit run code and see if it's going to work. All right, it's accepted. Now let me hit submit. Should work, might not be very ideal. All right, accepted. It might not be very ideal. You see it's 25% or 25%. But at least this is one way to get the problem solved, and I thought it's very straightforward. Now let me just remove this condition. We don't really need it. It should work as well because we break out here. Oh, unreachable statement. I don't really need this because it's going to break out. Let me just hit submit again. All right, it's also, oh, it's actually faster, 100%. Okay, let me just hit submit again to see if there's any difference. All right, now it shouldn't make that big of difference because we always break out from this if loop. From this if condition, it breaks out directly. Just hit one more time. Yeah, this sounds about right. It shouldn't make any difference. All right, this is the way that I approach this problem. I hope it makes sense. Because there are 3 participants, we always reserve the biggest one, the coins with the biggest value, maximum value, to Alice, and the smallest one to Bob. I take the middle one. So that's how we can solve this problem. I hope it makes sense. If it does, just do me a favor and hit the like button. That's going to help me out tremendously and help with the YouTube algorithm as well. And don't forget to subscribe to my YouTube channel, as I have accumulated quite a few LeetCode or data structure or algorithm tutorials or Amazon Web Services certification exam tutorials. So hopefully I'll just see you guys in just a few short seconds. That's it for this video. Thank you very much for watching.